Hey guys, we're continuing our unit on exponential functions, taking a baby step forward. We're going to look at equations, tables, and graphs and identify if they are linear, quadratic, or exponential. So for equations, which I think is one of the easier pieces here, you're going to, if your function is in slope-intercept form, so y equals mx plus b, you're going to have a linear function. Okay, so you're going to have a slope there. Y equals just your x variable is just a 1. Your highest variable there is a 1. And so that would give you a line. We've looked at that pretty in depth now. Then if you have y equals ax squared plus bx plus c in any form, then you're going to have a quadratic. And what you want to look for there is your highest exponent of x is going to be 2. So linear, your exponent is 1. Quadratic, your exponent is 2. Then dropping on down to the exponential function is y equals ab to the x power. So, and basically what you're looking for here is you're looking to see that your variable, that x is in the exponent. Okay, so we have a variable, you have an exponent of 1, we have an exponent of 2, and then we want to see if that x is the exponent. And so that's what we're looking for there. So if you'll notice here, I'm going to circle these corresponding to the certain color. So we have 15 times 0.8 to the x power. So since x is in the exponent, this is going to be exponential. And then I have y equals x plus 5 to the second power. So my highest power there is 2. So that's going to be a quadratic. And then I'm going to have y equals 3x plus 7. That's in slope-intercept form. The highest power there is a 1. So therefore, I'm going to have a linear function. And then moving on to the right, I have y equals 14 to the x power. So since x is in the exponent, this is going to be an exponential function. And then I have y equals 7x squared minus 8. And since I have a 2 in the exponent, this is going to be a quadratic function. So just looking at that and identifying there. Now let's look at the tables. This is a little bit more challenging, if you will, just because some of these it's a little bit harder to tell. So what you'll notice here is you want to look to see first if it's linear, it will have a constant rate of change. So notice that I'm adding 2 here, adding 2 here, adding 2 here, and adding 2 there. So you're looking for that constant rate of change, or CROC. There you go. So constant rate of change, you're looking for that, and whether it's going up or down, but it's still changing at the same rate. And then this is a linear. And then for the quadratic, that will be in the middle there. You're looking for a vertex. So if you'll notice, so remember we had to find that to find the domain and the range. When we had to find the domain and range of quadratic functions, we had to identify that vertex. So that was that bottom point or the top point. So what you'll notice here is that I have a 0, 0 as my vertex because 1 and 1 start bouncing back and forth, 4 and 4, and then so forth and so on. Those would bounce back and forth every single time. So for quadratic, you're looking for that vertex point, that point that it bounced off. All right, so I had a little mishap here on my math. I did not double check myself, and I'm getting kind of rusty on my math. So, so my last function here is going to be exponential. And then, so I have 1/25 and 1/5, 1, 5, and then 25. So the pattern that you're looking for here is a multiplication piece there, whereas for linear, we're looking to add. For exponential, we're going to look to multiply. Now, the two fraction pieces there, that might be a little bit more difficult to find the multiplication piece there. But when you look at the whole number, so 1 times 5 is going to be multiplied, and then 5 times 5 is being multiplied. So both of those are multiplying by 5. 1/25 times 5 is going to give you 1/5. 1/5 times 5 is going to give you 1. So it all ends up being a multiplication there. So you're looking for multiplication pieces every single time in the y values. And on all the tables, it's going to start off with -2, -1, 0, 1, and 2. So you don't have to worry about what if that changes. So all those are going to be the same. All right, and then the graphs, which is pretty straightforward here. So if it makes a line, it's going to be linear. And then if it makes a U or a parabola or an N, could be upside down and could look like this, then that is going to be a quadratic. And then the last piece here, if it's going to kind of approach an asymptote, so it looks like it's kind of leveling off, then that is going to be an exponential. So what you'll notice here is that my exponential function is going up. Okay, so if you've seen any graphs about the coronavirus, it's an exponential function, okay? Because one person infects 2 people, 2 people infect 2 more, and it starts dividing out. So one person can affect several people over the course of several days. That's why this is kind of becoming a big deal. So the exponential function there is going up. So that's an exponential growth. So that's going to be something that's growing exponentially. You want your money to grow exponentially. So any kind of savings pieces there, banks want your loans to grow exponential so that you pay them back more. You're charging more for those. But for decay, so that's what we want to see from the, we want to see this come back down, is that for the coronavirus, is it starts way up here and then it starts coming down and approaching 0 there. I know that to your naked eye looks like that it crosses the x-axis, and it might. Let's see if I can do a little bit better job. It's going to approach 0. Okay, so this is going to be a decay. It's still exponential, but it's going to be a decay. It's approaching a certain number. So it starts up really high and then comes back down and approaches that number there. Okay, so growth and decay for both of those are exponential, just like quadratic, where you have the positive that comes down to a U, and then you have the negative that looks like the N, and then you have linear, you have a positive that goes up, and then you have a negative that comes down, both representing different things there. Okay, so this is pretty much what your skill check is going to look like. You're identifying linear, quadratic, or exponential, or neither. Is it neither one of these? So just kind of keep your eye out for a neither one. All right. So again, looking for graphs, just looking at it. And then for tables, for linear, you're looking for that constant rate of change. For tables, you're looking for for quadratic, you're looking for the vertex, and then exponential, you're looking for a multiplication piece there. And then for equations, you're looking for that certain form for it to fit into either a linear or quadratic or exponential. You can always graph those on desmos.com/calculator and see, if you plug in an equation, see what that looks like. So you can go there. All right, so that's it for our intro to exponential functions.